Welcome to Kapati Mathematics classes. This is Murali Krishna. This is the 17th video on trigonometry. In this video, we are going to discuss about submultiple angles. Already we know what is meant by a submultiple angle. If A is any angle, then this A by 2, A by 3 and so on, all are called submultiple angles. Of A. Now in this lesson what we are going to discuss? We are going to discuss the values of trigonometric ratios for the angle A in terms of A by 2, in terms of A by 3, or the values of trigonometric ratios of angle A by 2 in terms of angle A. That means simply expressing sin A in terms of sin A by 2. Of course, sin A in terms of cos A by 2, sin A in terms of tan A by 2. Similarly, expressing sin A by 2 in terms of sin A, expressing sin A by 3 in terms of sin A. So overall, what is the lesson? Expressing the values of trigonometric ratios of angle A in terms of A by 2, or values of trigonometric ratios of angle A by 2 in terms of A. These are expressions. Okay, now we proved some formulae in the previous video, like sin 2A. Sin 2A is equal to 2 sin A cos A. Now, this is an identity that means it's true for all the values of angle A. It is true for all the values of A. Okay. Now, if you observe carefully, whatever angle you have here 2A, that is becoming half of that. That means if you have sin 30 degrees here, it will become 2 sin 30 by 2 cos 30 by 2. That means it will become 2 sin 15 degrees and a cos 15 degrees. That means this angle is becoming half of that. This is the main concept. This is. So now I am going to derive some formula using very simple technique. Now, number 1, basic formula sin A I am. So it will become 2 sin, it will become half of A, that means A by 2, and cos A by 2, the simple form, and cos A is equal to, you have cos square A by 2 minus sin square A by 2. Similarly, we have tan A is equal to 2 tan A by 2 by 1 minus tan square A by 2. These are the 3 basic formulae. Using this, I am going to the next term. The first derivation is sin A is equal to 2 tan A by 2 by 1 plus tan square A by 2. The first derivation. Okay. Now, how proof? Very simple. Take sin A is equal to, you have 2 sin A by 2 cos A by 2. Okay, what I do simple. It can be written as 2 sin A by 2 cos A by 2 by 1. because if you divide any number by 1, value won't change. Now 2 sin a by 2 cos a by 2. I have a famous identity in trigonometry. One can written as cos square a by 2 plus sin square a by 2. So I am going to divide both numerator and denominator by cos square a by 2. Dividing by cos square a by 2. Both numerator and denominator. So we get 2 sin a by 2 cos a by 2 by cos square a by 2 by this cos square a by 2 will become 1 and this sin square a by 2 by cos square a by 2. Now here what happened? Cos a by 2 will get cancelled, sin by cos will get tan by 1 plus sin square by cos square, nothing but tan square. So we could derive tan sin a is equal to 2 tan a by 2 by 1 plus tan square a by 2. Cos a is equal to, I write here, cos a is equal to 1 minus tan square a by 2 by 1 plus tan square a by 2. It's a very simple proof. Consider cos a is equal to cos square a by 2 minus sin square a by 2. Technique is same. I am going to write by 1 and this can be written as cos square a by 2 minus sin square a by 2 by 1. In the place of 1 I am writing cos square a by 2 plus sin square a by 2. Now same technique, divide both numerator and denominator by cos square a by 2. Dividing both numerator and denominator by cos square a by 2. Obviously cos square a by 2 by cos square a by 2 equal to 1. Sin square a by 2 by cos square a by 2 is tan square a by 2 by same thing 1 plus tan square a by 2. So sin a in terms of tan a by 2, sin a cos a in terms of tan a by 2. Already you have tan a, already we have formula. Tan a is equal to 2 tan a by 2 by 1 minus tan square a by 2. So I could express sin, cos, tan in terms of tan a by 2. Sin a by 2 cos a by 2 and tan a by 2 in terms of cos a is our next one target. Okay, for this one. First number one, expressing sin a by 2 in terms of cos a. For this one, I consider cos A first. Consider cos A is equal to, you have formula cos square A by 2 minus sin square A by 2. I want sin A by 2, so I express cos square A by 2 in terms of sin square. You know, very well known formula, 1 minus sin square x by 2 minus sin square x by 2. So totally I have 1 minus 2 sin square x by 2. Therefore we have 1 minus 2 sin square A by 2 is equal to cos A. Now you have to express sin A by 2 as subject. This implies we have 2 sin square A by 2 is equal to 1 minus cos A. This implies sin square A by 2 is equal to 1 minus cos A by 2. Therefore, sin A by 2 is equal to plus or minus square root of 1 minus cos A by 2. So sin A by 2 is equal to plus or minus root of 1 minus cos A by 2. This plus or minus depends on position of A by 2. Please remember this. Again repeat. Plus or minus sign depends on position of A by 2. That means if A by 2 lies in first quadrant or second quadrant, it will become plus. If A by 2 lies in third quadrant or fourth quadrant, you get a minus sign. Okay? Therefore, we have sin A by 2 is equal to okay, next one. B. Expressing cos A by 2 in terms of same cos A. Method is same. Okay, consider cos A is equal to cos square A by 2 minus sin square A by 2. Now I want cos A by 2 as subject, so I write sin square A by 2 in terms of cos square A by 2. This implies cos square A by 2 minus 1 minus cos square A by 2. So we get cos square A by 2, cos square A by 2, 2 cos square A by 2 minus 1. So we have 2 cos square A by 2 minus 1 is equal to cos A. This implies, I am skipping some steps, we get cos A by 2 is equal to 1 plus cos A by 2. Of course, here also plus or minus square root. So cos A by 2 is equal to plus or minus root of 1 plus cos A by 2. Okay. Now C. C is expressing tan A by 2 in terms of cos A. It's very simple. We have tan A by 2 is equal to sin A by 2 by cos A by 2. And sin A by 2, just now we got plus or minus root 1 minus cos A by 2, and this is 1 plus cos A by 2. So we get plus or minus under root of 1 minus cos A by 1 plus cos A. So we can express sin A by 2 in terms of cos A, cos A by 2 in terms of cos A, tan A by 2 in terms of cos A. These three are very, very useful identities. Please take it. expressing sin A by 2, cos A by 2, tan A by 2 in terms of sin A. This is the next one. So, proof or derivation. For this one, I am going to consider two identities. Number one, we know cos square A by 2 plus sin square A by 2 is equal to 1. Let equation 1. Next one, you know very well, 2 sin A by 2 cos A by 2 is equal to sin A. Number 2. Now, I am going to add both of them. One case, I am going to subtract both of them. Other case. Okay, your first one. Add 1 plus 2. So, we have cos square A by 2 plus sin square A by 2 plus 2 sin A by 2 cos A by 2. And this right hand side will become 1 plus sin A. If you observe carefully, this is a square plus b square plus 2ab, nothing but a plus b whole square. This implies we get cos a by 2 plus sin a by 2 is equal to whole square is equal to 1 plus sin a. Or we have cos a by 2 plus sin a by 2 is equal to plus or minus square root of 1 plus sin A. Let this is 3. Now next time if you subtract 2 from 1, you get cos A by 2. We get cos A by 2 minus sin A by 2 whole square is equal to 1 minus sin A. Therefore, or we have cos A by 2 minus sin A by 2 is equal to plus or minus under root of 1 minus sin A. Let this is 4. Now, if I want sin A by 2, what I do? I add these 3 and 4. So, now next one is 3 plus 4. When you add these two will get cancelled. You get 2 cos A by 2. So we have cos A by 2 is equal to plus or minus root of 1 plus sin A plus or minus root of 1 minus sin A, of course, by 2. So I got cos A by 2 in terms of sin A. Next time, I will go for 3 minus 4. 3 minus 4, these 2 will get cancelled, it will become plus. So we have sin A by 2 is equal to this plus or minus, it won't change, plus or minus root of 1 plus sin A. And this plus or minus will become minus or plus root of 1 minus sin A, of course, by 2. And finally, what is the tan A by 2? Tan A by 2 is nothing but sin A by 2 by cos A by 2. Sin A by 2 by cos A by 2. And sin A by 2 is equal to this, and cos A by 2 is this. So, just division. Plus or minus under root of 1 plus sin A minus or plus under root of 1 minus sin A by plus or minus under root of 1 plus sin A plus or minus under root of 1 minus sin A. So I could express cos A by 2 in terms of sin A, sin A by 2 in terms of sin A, tan A by 2 in terms of sin A. Please take it. Next one, express sin A by 2, cos A by 2 in terms of Sin A by 2, cos A by 2, tan A by 2 in terms of tan A. That is the next lesson, that is. Next one, express tan A by 2 in terms of tan A. Okay, now derivation. Now we know tan A is equal to 2 tan A by 2 by 1 minus tan square A by 2. So what I do, or 1 minus tan A times tan A minus tan square by 2 times of tan A is equal to 2 tan A by 2. Okay, now what I do, I write tan A times of tan square A by 2 plus 2 tan A by 2 minus tan A is equal to 0. If you observe, it's a quadratic equation in terms of tan A by 2. So I can write, therefore, tan A by 2 is equal to minus b, or minus square root of b square minus 4ac, 4 into 1 plus tan square A by 2 tan A. Of course, bring 4 outside, become 2 will get cancelled. So we have minus 1 plus or minus under root of 1 plus tan square A by tan. Okay, please.